So we've covered the straight line, we've covered the parabola. Let's combine them and see what we can find when we're asked all sorts of questions when given two functions on the Cartesian plane. I'm trying to do this in a very systematic, simple method. So today I'm going to flick through 3 different situations and go over the same kind of question in each scenario. And we'll extend on that as we go along. But today, this quick little concept is just going to cover that of finding the specific coordinates on the sketches that have been given when we've been given the equation of the sketch. So let's have a look. I've been given fx is equal to negative x squared plus 4. Now you need to realize that when you see an x squared, we're talking about a parabola. And I want you to take the information that's given to you and highlight it in a certain color, and then go and highlight the graph on the Cartesian plane in that same color so that it stands out to you. I am highlighting my parabola in purple. Let's do the same for the other function, which I'm sure you've guessed by now. The other function is gx, which is given by 2x plus 4. And so I'm going to go and highlight my straight line in green as well. Now we can perhaps focus a bit easier on either one of them. The question asks us to find the coordinates of the points A, B, and C. I remind you that coordinates are always in the format x and y. So if they're asking for coordinates, we need to find the x part and the y part of each of these coordinates. As you can see, the parabola, the purple parabola, flows through A and B, and to be more specific, A and B lie on the x-axis. So when we're asked to find the coordinates A and B, we're just looking for the x-intercepts. And how do we find x-intercepts for any function? We make y equal to 0. Now note that this is function notation where they say fx equals negative x squared plus 4. You are welcome to replace the fx with a y since we're dealing with a y-axis and an x-axis. So in order to solve for x, we're going to go 0 is equal to negative x squared plus 4. How do we solve this quadratic equation? Well, we need to factorize into 2 brackets, and I hope you're feeling it, that it's going to be a difference of squares. However, we don't like that negative out there in front of the x squared, so I advise you to move all your terms over to the left-hand side of the equal sign, changing their signs, and then making our difference of squares scenario a whole lot easier. X is therefore negative 2, or x is equal to positive 2. Now these are 2 solutions to one equation, which is wonderful. We've just killed 2 birds with 1 stone, because I'm sure you agree that the coordinate of A is going to be negative 2 in the x part, and the coordinates of B will have positive 2 in the x part, because we found the 2 different intercepts. A parabola should have 2 x-intercepts if it crosses that x-axis. Now the y part of those coordinates is easy. What did we set y to be when we solved for those x values? You guessed it, y was of course 0. Any and every x-intercept will always have a corresponding y value of 0. So therefore, when we write our final answers, our A would be negative 2 and 0, and our B will be positive 2 and 0. Those 2 coordinates is what you'll be awarded for in terms of marks. So please be aware that you need to follow instructions. If you're asked for coordinates, give your answer as coordinates. Okay, moving on. Oh, they've also asked for point C. How could I forget? Let's zoom in there to see. Do you see that C is the point at which both functions, the green and the purple, parabola and the straight line, cross the y-axis? So you guessed it, C is, of course, the y-intercept. Now, since we've been given both of the equations, we can read off the y-intercept as 4. If the equations were not in standard format, how would we determine the y-intercept? We would just set x to be 0 and then solve for y. So the coordinate of C would have 4 in its y part, and of course every single y-intercept's corresponding x value would be a 0. So there we have an additional coordinate, and we've answered the question. See? Just put that in red. Not so bad. If you feel confident and you don't need to hear the explanation again, pause the video and find the coordinates of points A, B, C, and E yourself. Otherwise, you can continue watching because I'll do it. I'm just going to do so at a faster pace. If we zoom in, look at which coordinates lie on which graph. Right, first things first, I'm going to choose a color for each of my different functions. I see that fx is given by x squared minus 9. So, and it's also been labeled for us, fortunately. So I'm highlighting my parabola in yellow. The exponent of 2 will always belong to the parabola. Here the x has no exponent, or it has an invisible 1 as an exponent, so that's our linear function, which I'm highlighting in blue. Now I can clearly see that points A and B lie on the parabola. A also lies on the blue straight line. So if I want to find the coordinates of A, I can either find the coordinates of the x-intercepts of the parabola, or I could find the x-intercept of the blue line. Let's kill 2 birds with 1 stone and just find the x-intercepts of the parabola, which is called the f graph. So once again, we set y to be 0. Therefore, 0 is equal to x squared minus 9. Difference of squares again, leaving us with 2 lovely solutions, making that very logical conclusion that the left value will be the one that's on the left-hand side of the y-axis. So the negative value is on the left-hand side of the y-axis, the positive value is on the right-hand side of the y-axis. And so we have our 2 coordinates. Don't forget to write it in coordinate format, x and y values. Right, now the other part of the question is asking for the coordinates of C and E. Do you see that the point C is where the blue line crosses the y-axis? And so C is just the y-intercept of our blue straight line, mx plus c. So we know that our y-intercept must occur there at 6, corresponding value being x value being 0. The y-intercept of the parabola occurs there at point E, and so the y-intercept is given by the constant in the equation. So E is also easily written down in one step as the coordinates 0 and negative 9. Please reach out to me if you're not following, if something is confusing you. Now is the time to try and establish a question and send it to me. Otherwise, pause the video and do number 3. I'm going to leave this blank for you to do. Submit the calculations for A, B, C, and D in the section below, and I will mark them and give you feedback as to whether or not you have found those coordinates. That is the end of part 1 of applications of functions, just finding specific points. The next video will lead into the next kind of question we can ask you.